Welcome back to the second part of our topic of multiplication and division of fractions. And now that we have covered multiplication, we'll now be looking at division of fractions, but from a visual lens to build a deeper understanding. So if we look at the slide, we can see we have a division problem which asks us to find 1 over 7, or a seventh divided by a half, or 1 over 2. So what this is asking us is to essentially find how many groups of a half can be derived or found in 1 over 7. Now, when you hear that, you may be trying to visualize or conceptualize visually what that actually means. But to make things a bit more understandable or easier to digest, let's think of our regular whole numbers, i.e. 1, 2, 3, 4, 5, etc. So if we take this for example, 6 divided by 2, what that is asking us is essentially how many whole groups of 2 can we find from 6 whole ones. So how many groups of 2 can we find in 6? So as you can see, we've got 6 circles, or let's say these are counters or coins or whatever you want to call them. So we have 6 counters, for example's sake, and we want to find how many groups of 2 can we collect from these 6 counters. So if we draw out groups of 2, we have 1, 2, that's one group, 1 group, and 1, 2, and that's another group. So altogether we have 1, 2, 3 groups of 2, because there are 1, 2 in that's one group, 1, 2 another group, 1, 2 and another group. So that means there are 3 groups of 2 altogether, which gives us our 6 counters altogether. 1, 2, 3, 4, 5, 6. So that's how we know that 6 divided by 2 is 3, because there are 3 groups of 2 in 6 altogether. Now, if we go back to our original problem, where we're asked to find 1 over 7 divided by 1 over 2, again, that is asking us to see how many groups of a half can be derived or found from 1 over 7. So we have 2 squares given to us. So let's say this square represents 1 over 7, and this square represents our half quantity. So if we look at the first square, if we want to represent 1 over 7, that means we need to split this square into 7 pieces and shade one of those pieces to represent 1 over 7. So if we split our square into 7 vertically, so that's 1, 2, 3, 4, so 1, 2, 3, 4, 5, 6, and 7. And if we shade one of those, so let's shade this one to show 1 over 7. And because our half is shown on this side, this means we have to split the square horizontally into half. So let's choose a different color. So this square represents 1 over 7 with one piece shaded, but then we've split the square into half to represent our half because it's on this side of the square. So this square now represents a half. So we've done this square. So let's just represent, this is 1 over 7 divided by a half. So this square represents our half of the problem. So if we split this square into half, and a half means we split the square into two and we shade one of the pieces. So this means our half is represented. And because we have 1 over 7 on the top, this means we have to split the square into 7 pieces vertically. So that is 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, and 7. Okay, so our first square represents 1 over 7. So we split the square into 7 and shaded one of the pieces. And then we split the square again into half to show our half. Then this square shows us a half because we first of all split the square into two, shaded one of the halves, and then from there we split the square into 7 pieces vertically to show our 1 over 7 quantity. Now, okay, so if we want to find how many halves are in a seventh, so how many groups of a half can we derive from 1 over 7? So if we look to our second square, we need to find out how many pieces make up a whole or make up a half group. So if we count, there's 1, 2, 3, 4, 5, 6, and 7 pieces. So because there are 7 pieces, that means 7 pieces make the whole of our half, because there's 1, 2, 3, 4, 5, 6, 7, and these 7 pieces make up half of the square. So that means 7 pieces is equal to a half, which is what we're going to use to solve our problem. So what we do is we want to find out how many of these pieces can we fit into our 1 over 7 over here. So if we count, let's just imagine we want to find how many of these pieces can we fit into our square over here. There should be 1. So let's say this one comes over here. And then 2. Let's just imagine this is over here. And so only 2 of the pieces have managed to fit into our first square over here, which means out of the whole there are 2 out of the 7 pieces which have managed to fit into our first square over here. Remember, this square represents 1 over 7, and because we split it into half, that means there's 2 pieces that we've managed to find out of the 7 here. So from there, we can say that it's 1 over 7 divided by 1 over 2 is equal to 2 over 7. And of course we can check by just, again, if we were to recalculate the answer just by using a written method, this would be 1 over 7. So we flip the second fraction times 2 over 1, which obviously is 2 over 7. So we can see the method still checks out because we still get the same answer. So because only 2 of the pieces out of the whole group of a half fit into our first square, that means our answer would be 2 over 7. So if we look at a second problem, we have a half divided by 2 over 3. So again, we're asking ourselves how many groups of 2/3 can we fit in or find from a half. So let's imagine, or let's say this first square represents a half, and this square represents 2/3. So a half means we split our square into 2 and shade one of the pieces. So this is done vertically, and horizontally 2/3 would be splitting in the square into 3 and finding how many pieces we get all together from splitting the square into 3. So we have 1, 2, and 3. So we have 1, 2, 3 shaded pieces all together from splitting the square into 3 and splitting it into half and then shading the half. So if we look at our second square, we have 2/3 and a half on the second square. So this time we're going to represent 2/3 first. So that means we split our square into 3 and then shade 2 of the pieces so this shows us 2/3. And then we show a half. So a half just means dividing the square into 2. So this is our group of 2/3. So if we wanted to ask ourselves how many pieces make up 2/3, or our whole in this case. So there's 1, 2, 3, and 4. So 1, 2, 3, 4. 4 pieces make up 2/3 because there's 1, 2, 3, 4, and 2/3 of the square is shaded horizontally. So let's just write this down. So 4 pieces make up 2/3. And so our half is represented by 3 shading pieces in our first square. So what we want to do is find out how many of these pieces can we fit into our representation of a half on this square. So if you imagine moving each piece of this division here, so 1, 2, 3, 4. If you imagine moving one piece, the second and the third, so that would be moving this piece would be go over here. The second piece comes here, and let's say the third piece goes over here. So only 3 out of the 4 have managed to fit into our first square over here, which means our answer is 3/4 or 3/4, because out of a half we have managed to get only 3 of the pieces to fit into our first square. And remember, 4 pieces make up the 2/3, but only 3 have managed to fit into our first square. So that leaves us with a half, we can also check this, times 3/2, because we flipped the second fraction, remember. So our answer would be 3/4. So we still get the same answer. So that will be how to solve that problem. So in the video, we explored multiplying and dividing fractions, but also going beyond just the rules to truly understand how they both work, and also the use of visual models to represent both operations. And by visually seeing these concepts, you can better grasp why these calculations work, which should hopefully make more sense as you become more familiar with fractions. So, okay. So that's all for today's video. And if you found the video useful, don't forget to like, subscribe, and hit the bell icon so you never miss a new upload. And if you have any questions, drop them in the comments below and I'll be happy to help. Take care, and I'll see you in the next video.